My dear friends, let me discuss the concept of oscillations, in which we have to prove that a body which is going in an anticlockwise direction in a circular motion is going to represent simple harmonic motion. And how is it going to be possible? Let us see here now. Let us consider the particle is moving in an anticlockwise direction with a constant velocity. Velocity is going to be constant here. Okay. So if velocity is going to be constant, let us drop one perpendicular along the xo x dash and another perpendicular here and here, which along the yo and y dash, two x-axis and y-axis. Now, in this case, if you take this an angle as theta, which can also be taken as omega t, because angular velocity is nothing but angular displacement by time, and angular displacement is nothing but angular velocity into time here. So therefore, if this is sine omega t, now let us take the distance from here to here as x and this distance as going to be y here. So in such situations, if this is y, this is also going to be y here. Now let me write here cos omega t, which is taken as this angle and adjacent side is x, and this is going to be radius and also called as amplitude. Why is it amplitude here? This is going to be a mean position and this is going to be an extreme position. So from mean position to extreme position, if displacement slowly increases, it is going to become an amplitude. So therefore, this can be taken as radius and it is also going to be an amplitude here. So therefore, cos omega t is nothing but adjacent side by hypotenuse. So here, x can be taken as r and also taken as r is can also be taken as a here. So a. So it can also be taken as a cos omega t. Similarly, if you take sine omega t. So this sine omega t can be taken as opposite side, that is y, and hypotenuse is taken as an amplitude, that is a here. So I can write this as y is equal to a sine omega t. Okay. So if this is y is equal to a sine omega t, we can find out velocity also, because we got displacement along the x-axis and along the y-axis. Then here, so displacement along the y-axis, if you consider, we can find out the velocity by just differentiating this concept here. No, we are going to differentiate the above one, getting velocity here, that is dy by dt. If you differentiate this one, amplitude is going to be constant and sine omega t can be taken as cos omega t after differentiation, and this omega t, if you differentiate, you are getting omega here. That's why you write, and dt by dt gets cancelled here. So double time you have to differentiate. We're getting velocity now. So therefore, we got velocity as a omega cos omega t. Okay. How can we find out an acceleration? If you differentiate velocity once again with respect to time, you are getting acceleration here. So acceleration is nothing but dv by dt. That means you have to differentiate all this. So here, this can also be taken as a omega. If you differentiate cos omega t, you will be getting minus sine omega t. And again, if you differentiate omega t, you will be getting omega once again, and dt by dt gets cancelled. So one more omega if you add here, if you multiply here, getting omega square here. Okay. So therefore, acceleration is equal to minus, so omega square, and here a sine omega t is taken as y. So here also a sine omega t can be taken as y, which is nothing but omega square into y. So we got velocity, we got acceleration, we got velocity here. How much is going to be the velocity? Velocity is a omega cos omega t. Okay. If you want, you can take capital A omega cos omega t. So what is going to be the maximum velocity? Velocity is going to be maximum at the mean position, and at extreme position it goes to stop, another extreme position it is going to stop. So velocity is going to be maximum at the mean position. Therefore, at the maximum velocity, the maximum value of cos omega t is 1. Angle for trigonometric functions like cos omega t lies between -1 and +1. So maximum value of cos omega t is going to be 1. Therefore, V maximum is going to be omega a. Then if you get an acceleration as minus omega square y, then what is maximum acceleration? Maximum acceleration can be taken as minus omega square a. Here y is going to become a, because acceleration is maximum at the extreme positions and minimum at the mean position. Okay, so acceleration is always directed towards the mean position. Therefore, we are getting acceleration as maximum, which is minus omega square into a. That's it.